Hello, I'm Yi Khan from University of Reading, Malaysia. In this video, I'm going to introduce to you the concept of indifferent curve. In this figure, the horizontal axis represents risk and the vertical axis represents expected return. The indifference curve is a curve connecting all portfolios with the same utility according to their expected return and standard deviations. Let's take a look at this example. Here, investor has two portfolios to choose, portfolio P and Q. If we move from point P, an increase in standard deviation lowers utility. It must be compensated for by an increase in expected return. Therefore, the point Q is equally desirable to this investor as P. All the portfolios that lie in the indifferent curve are equally preferred. An investor would be theoretically indifferent among the portfolios as they offer the same utility value. The portfolios with higher expected return also have higher risk. On the other hand, portfolios with low risk offer low expected return. Let's have a quick quiz to test your understanding. Which indifference curve would you choose? Why? The answer is IC2. Indifferent curves that are to the northwest of any other curve represent higher levels of utility. A portfolio with a higher level of return for the similar level of risk makes the investor better off. Let's have another quick quiz. Which investor is the most risk adverse? The answer is investor with risk aversion of 4. His indifference curve is steeper because he requires higher expected return for the same level of risk. I have one more question for you to think about. Can the indifference curve have different shape for different types of investors? Yes or no? The answer is yes. This is because coefficient of risk aversion can be negative, positive, and 0. How can we derive the indifference curve? Recall that the indifference curve is a curve connecting all portfolios with the same utility according to their expected return and standard deviations. Therefore, we can use the utility formula to derive the points x and y on the indifference curve. All we need to do is rearrange the equation of the utility by expressing expected return as a function of standard deviation. Let's draw an indifference curve using some data. For the curve, the x values are standard deviation, which we assume a value from 0%, 5%, 10%, and up to 50%. We use coefficient of risk aversion of 2 and 4 as input. We also assume two levels of utility, 0.05 and 0.09. We are going to use the formula of the expected return to calculate the y values of the indifference curve. The results are shown in this figure. Here we have 4 indifference curves. Observe the figure. What kind of characteristics about the indifference curve that you observe? Let's compare indifference curve with risk aversion of 2 and risk aversion of 4. Do you notice that both indifference curves for A equals to 2 have the same shape? Indifference curve for A equals to 4 is steeper than A equals to 2. This means more risk-adverse investors have steeper indifference curve than less risk-adverse investors. Steeper indifference curve mean that investors require a greater increase in expected return to compensate for an increase in portfolio risk. From the calculation, we also observe that a portfolio on the curve with utility of 0.09 offers an expected return of 4% greater than the corresponding portfolio on the lower curve. Higher indifference curves correspond to higher levels of utility. Therefore, a rational investor should choose a portfolio on the higher indifference curve. Thank you for watching this video. I hope you truly understand the concept of indifference curve. So far, I have recorded video on various basic concepts, including risk aversion, utility, and indifference curve. We shall have an exciting time ahead, combining all these basic concepts and apply them in portfolio management. Stay tuned and study hard. Bye.